Hey, hello guys, I'm back with a new video. In this video, I'm going to learn a new subject, that is inorganic chemistry, that is very useful for pharmacy students. And this you're watching Farm Pretty, where learning is made simple, easy and fun. So in this video we are going to learn about limit test. So limit test is defined as quantitative or semi-quantitative test which is designed to detect any chemicals or any small type of quantities of impurities present in the substances by determining its turbidity or opalescence in the test. So this is actually take place in the lab to find out any impurities present in the particular sample. For example, you're taking some Kellogg's at morning, so they will usually test any purities or any chemicals or present in that Kellogg's, so that when you're taking that you will not be get any poisonous or any allergy to that. So this limit test, how does they find out this? You may have doubt, right? This is based on the opalescence or turbidity of the sample. They will compare the sample with the standard so that you can easily understand which one is more poisonous and which one is less poisonous. For example, the test has more color or more turbidity, then the test has failed. This is compared with the standard. The standard may have the standardized chemicals, right? It may be 0.001% impurity in it, but the test may have more than that. So this is what the comparison between this test and standard. So first we will do the limit test for iron or anything else. Then we will compare the test solution with the sample solution. By comparing with the standard solution, you may have understand that the standard may have the higher intensity of color or opalescence or turbidity. Then means the test has passed the the sample has passed the test. Then if you are having the test as more color and more intensity or more turbidity, then the standard has passed the test. So this is what the limit test. So limit test actually has divided into three comparison methods. That is, first we will do the test or any reactions with that. Taking the sample, mixing with water or some chemicals, we will do that. Then the test will get any intensity or opalescence, anything else. So this will be compared with the standard. That is the second method, comparison method. Then this comparison method is quantitatively analyzed with the particular pharmacopoeial organism, pharmacopoeial substance. Like standard solution may have already 0.01 percentage iron. So when you're comparing with the test will may have more less than that, maybe 0.001. So this will be the quantitative determination of standard and test solution. These three methods are followed in the limit test. So first thing, you will do the experiment and the test will get some intensity of color or opalescence, etc. Then you will compare it with the standard. Other test solutions will be compared and then quantitatively analyzed the impurity. So first we can learn about the limit test for chloride. So limit test for chloride is a limit test or quantitatively or semi-quantitative test designed to identify and control small quantities of impurities which is likely to be present in the substances. This test involves in the reaction of silver nitrate with soluble chloride to form the precipitate of silver chloride, which is insoluble in dilute nitric acid. So this precipitate is formed because of the reaction between the soluble chloride and silver nitrate, which gives silver chloride as a precipitate. So this test we are using nitric acid to avoid the other substance to react into the substances. Then the opalescence produced in the test solution is compared with the standard solution under the same experimental conditions. So first we can learn about the what are the procedure we do it. So we take two Nestle cylinder and label one as standard and one as test. So we'll take the test and just dissolve the substances as mentioned in the IP monograph and add 10 ml of distilled water. Then add 10 ml of nitric acid. Then make up to 50 ml with distilled water and then add 1 ml of silver nitrate solution, 0.1 molar silver nitrate solution, and stir immediately with glass rod and allow to stand for 5 minutes. So this procedure is done in the test. So as you are making the test, the same time only you should make the standard too, because we have to compare at the same time. So the standard may have been done like, you should pipette out 1 ml of the standard solution and transfer into the Nestle cylinder. And then you should dissolve 10 ml of distilled water and follow the procedure as like the test. We should add nitric acid, 10 ml of nitric acid, and make up the volume with 50 ml with distilled water, and then you should add silver nitrate solution and we should stir immediately. Then we should compare the opalescence with the standard solution. This is what the procedure we should do it. So this procedure actually very important to be noted, because this procedure is a standardized procedure and you should learn each and every quantities with it. So next we are going to learn about the limiters for sulphate. So limiters for sulphate is same as the chloride, but here the limiters are semi-quantitatively or semi-quantitatively used to control the impurities present in the sulphate. Okay, so the limiters for sulphate is based on the reaction between barium chloride and soluble sulphate in the presence of hydrochloric acid, and opalescence or turbidity is produced by the precipitation of barium sulphate in a fine state of divisions. Then we shall compare the turbidity with the standard solution. This test substance is past the limiter if the opalescence or turbidity in it is less intense than in the standard. If the opalescence or turbidity is found to be more, then it has failed the test. So barium sulphate reagent is used because it contains sulphate free alcohol and barium chloride and potassium sulphate. This alcohol will prevent the supersaturation and more uniform opalescence or turbidity is formed because of this alcohol. And this potassium sulphate is used because it will increase the sensitivity, and also barium chloride is used to increase the seeding agents in it or act as a seeding agent for the precipitation. And then as we know, the acidic medium is used because to prevent other substances to react with it, so that we will get the perfect, correct and meaningful reaction in it. So next one is the procedure for it. So the procedure, as I have told, the same like chloride. What are the things you have followed in the chloride will be followed here. So the procedure of sulphate will be like, the test solution should take the same like the chloride. You should take 2 Nestle cylinder and make a test and standard. In the test you should add the sample as mentioned in the IP and then add 10 ml of distilled water. Then you should add 2 ml of dilute hydrochloric acid. So there in chloride we use 1 ml of nitric acid, but here we use 2 ml of hydrochloric acid. Then you should add 5 ml of barium sulphate reagents. Okay, this barium sulphate reagent has the barium chloride and sulphate free alcohol and potassium sulphate. So these reagents are added into it, and then we make up the volume with distilled water. Then we stir and we will leave for 5 minutes for the reaction. But in chloride, we add the dilute nitric acid first. Then we make up the volume. Then we added the silver nitrate. So we have 51 ml solution there. But here we add everything first, then only we will make up the volume. So we have totally 50 ml here in sulphate. There we have 51 ml in the chloride. So this is what the difference between chloride and sulphate. and same like chloride, we will compare the opalescence here. So this is what the procedure of sulphate. So next we are going to learn about the limit test for iron. So limit test or quantitative or semi-quantitative test designed to identify and control small quantities of impurities which are likely to be present in the iron. Okay. So the limit test of iron is based on the reaction between ferrous iron and thioglycolic acid in the presence of citric acid in an ammonial solution. So when a pale pink to a deep reddish color is produced when the reaction occurs. So the ferric ion is reduced to ferrous ion by a thioglycolic acid and the compound produced is ferrous thioglycolate. So the citric acid forms a soluble complex with iron and prevents its precipitation with the ammonia as ferrous hydroxide. So the ferrous thioglycolate is colorless in neutral or acidic solution. So only we cannot use the alkaline medium in it. So it is stable in the presence of air but fade when exposed to air, so that it oxidizes to ferric compound. Therefore the color should be compared immediately after the time allowed for the full development of color is over. So first the ferric ion is reacted with thioglycolic acid so that you can get a ferrous thioglycolate solution in the citric acid ammonia solution. So this is what the reaction involved in the limit test for iron. So the next procedure, so this procedure is not compared with the sulphate or chloride, it has a separate procedure. So as in every limit test you will have a two Nessler cylinder except in the arsenic and heavy metals. Arsenic and lead. So first in the limit test for iron, the procedure will contain two standard solution, standard Nessler cylinder, one as test and one as standard. The test consists of a sample or substance which you should be determined. Then add 20 ml of distilled water and then add 2 ml of 20% volume by weight by volume citric acid and then 0.1 ml of thioglycolic acid, and then to make the solution alkaline we add free ammonium solution so that we can make the volume up to the 50 ml. So here also first we add all the reagent, then we compare. At the same time we make the standard solution, we should be put of 2 ml and the same procedure is followed as like the test solution. Then here you should compare the intensity of the color between the standard and the test solution. So next is the limit test for heavy metals. So many heavy metals such as lead, iron, nickel, cobalt, copper, bismuth, etc. may occur as impurity in official substances. Their quantity is limited by ignition of limiter test for heavy metals. This gives a method which is the substance which forms a clear and colorless solution with sodium hydroxide or hydrogen sulfate solution, so that you can be comparing the intensity of the color with the standard. This gives a dark brown color to black, so you can compare easily with the standard solution. So the heavy metals react with sodium sulfate or sodium hydroxide solution and gives lead sulfate as the precipitate or metal sulfate as the precipitate. So the procedure is as like every limit test, we usually take two Nessler cylinder, that is test and standard. The test has a 1 gram of the substance and add 10 ml of distilled water. So next we have to add sodium hydroxide as a solution. Add 5 drops of sodium sulfate solution and then dilute to 50 ml with distilled water, then allow to stand for 5 minutes. The same has followed in the standard too. And then we usually follow 4 methods for making this. So next is the limit test for arsenic. Actually, this arsenic is present in two forms, that is arsenious acid and arsenic acid. So this arsenious acid is actually H3ASO3 is the formula of arsenious acid. There will be two 3 in it, whereas the arsenic acid consists of a 3 and a 4. So that we should reduce this arsenic acid into arsenious acid. So we usually add the substance and add hydrochloric acid so that we can convert into a either arsenious acid or arsenic acid is formed. Then if arsenic acid is formed, we should reduce it into a arsenious acid. So we add senaceous chloride or sulfurous acid so that we can get arsenious acid. Then nascent hydrogen is used so that it converted into arsine. So then it undergo reaction and it is stained as brown stain. So the basic procedure is what we have following here. Then this procedure of this is we usually take a special apparatus which is called as Getset apparatus. It consists of a tube and a clip and a rubber bands, and it has a mercury chloride paper at the middle of the tube, and the solution is consists of hydrochloric acid and then the sample, and you have the senaceous chloride in it. So when the reaction occurs, this arsine, converted arsine, just comes up and the paper is stained. Lead acetate is present in between because to avoid any of the hydrogen to escape from that and cause the stain. So this arsenious acid only cross this lead acetate and reach the mercury chloride paper. So this mercury chloride paper will be stained as brown or yellow so that we can found that there is an impurity of the arsenic in it. So this paper stain is compared with the standard solution. So this is what the limit test of arsenic. I think you clearly understand the limit test for chloride, sulphate, arsenic, heavy metals, and also I think you have detailedly known about what is limit test too. So tata bye bye from my video, and just follow my channel for more video and subscribe my channel. Don't forget to click the bell icon so as soon as I upload a video you can get the information. And also if you want any videos related to compounds or any notes related to compounds, just comment me in the comment section. I will upload you a video or a notes for that. So don't forget to subscribe my channel. Tata bye bye. See you later in my next video. Bye bye.